Hello, in this section, we will focus on counting techniques that involve combinations. Specifically, combination involving objects that are distinct. So the number of combinations of n objects taken at a time is given by the formula NCR equals n factorial over n minus r factorial times r factorial. So here the order does not matter. An object cannot be repeated, and also n objects are distinct. So this combination formula is same as the formula for the binomial coefficient. So let's look at some examples. So the first example is a kindergarten child is allowed to pick 2 toys from the goodie box for demonstrating good classroom behavior. How many ways can she pick toys from a box of 25 toys? You can see that the 25 toys in the box are distinct. So also the order of picking up the toys is not important. So this is a combination problem. So the number of ways she can select 2 toys from a box of 25 toys is given by the formula 25C2. So to evaluate this, we can use the combination formula here. N equals 25, R equals 2. So 25C2 equals 25 factorial divided by 25 minus 2 factorial times 2 factorial. Now we can evaluate this as like 25 factorial. We can write it as 25 times 24 times 23 factorial over 25 minus 2 is 23 factorial times, we can rewrite 2 factorial as 2 times 1. When we simplify this, we'll get 300. So number of ways she can select 2 toys from a box of 25 toys is 300. Let's look at another problem. A football coach must decide who are going to be the team captains for the last game of the season. There will be 5 team captains for the last game. How many distinct sets of team captains are possible if there are 52 players on the team? So here we can see that the 52 players are distinct, and also the order is not significant. The order of selecting is not significant. So we can see that this is a combination problem. So the number of different ways the coach can select 5 team captains from a team of 52 players is given by the formula 52C5. So here n is 52 and r is 5. So you can use the combination formula n factorial over n minus r factorial times r factorial. So we can rewrite 52C5 as 52 factorial over 52 minus 5 factorial times 5 factorial. So 52 factorial over 47 factorial times 5 factorial. To evaluate this, we can rewrite 52 factorial as 52 times 51 times 50 times 49 times 48 times 47 factorial. So that it will cancel with the 47 in the denominator. Then we can write 5 factorial as 5 times 4 times 3 times 2 times 1. When we simplify this, we'll get 2,598,960. So the number of different ways the coach can select 5 team captains from a team of 52 players is 2,598,960. 598,960. Let's look at another problem. A neighborhood contains 5 coffee shops, 3 pizza restaurants, and 2 sushi restaurants. 3 of the businesses are to be chosen at random. How many possible outcomes are there? So this is about restaurants. So out of the 10 distinct business, we have to choose like 3 of them. So there are 10 distinct business, and the order in which the business are chosen is not important. So again, this is a combination problem. We can use the combination to solve this problem. So a number of possible outcomes, that is like number of combinations of the 10 business chosen, 3 at a time. So the formula is 10C3, and 10C3 equals, by using the combination formula, we can rewrite it as 10 factorial over 10 minus 3 factorial times 3 factorial. So when we simplify this, we can rewrite 10 factorial as 10 times 9 times 8 times 7 factorial, and we have 7 factorial in the denominator that will cancel each other. We can rewrite 3 factorial as 3 times 2 times 1. So when we evaluate this, we'll get 120. So number of possible outcomes is 120. So let's look at the last problem. It's also about the restaurants, but it's specifically about the coffee shops. A neighborhood contains 5 coffee shops, 3 pizza restaurants, and 2 sushi restaurants. 3 of the businesses are to be chosen at random. Of the total number of possible outcomes, how many would consist only of coffee shops? So this is specifically about the coffee shops. We know that altogether there are 5 coffee shops. They are distinct, and also the order in which these coffee shops are picked is not significant. So we can use combination to solve this problem. So the number of ways in which only coffee shops are selected. So we can see that there are only 5 coffee shops, out of which we have to choose 3. So we can use the combination formula 5C3. So we can evaluate 5C3 as 5 factorial over 5 minus 3 factorial times 3 factorial. So we can rewrite 5 factorial as 5 times 4 times 3 factorial over 2 factorial as 2 times 1, then 3 factorial here. So we can cancel these 3 factorial in the numerator and denominator. So the final answer is 10. So the number of combinations of the 5 coffee shops picked 3 at a time is 10.